Hello. In this video, I'm going to be showing you how to simplify square roots when the radicand is negative by using the perfect squares method. When you are using the perfect squares method, it's important that you know your perfect squares. So over here, I've listed the first 7 perfect squares. On example 1, I have the square root of negative 48. And the first thing I'm going to do is I'm going to break this up into the square root of 48 times the square root of negative 1. And the reason why I'm doing this is because I know that the square root of negative 1 is the number I. And so that part of this problem, we already know. This is an imaginary number because it has that negative in the radicand, and so I is going to be a part of my number. To simplify the square root of 48 using perfect squares, you need to think about what perfect square is a factor of 48. And that is going to be 16. And I know that 16 times 3 is 48. Let me write this a little bit better. And so again, I just broke up 48 into its factors, the square root of 16 times the square root of 3. The square root of 16 is 4. The square root of 3 cannot be simplified any further. And I also have this I. I'm going to move this I in front of the radical, so that my answer is 4i square root of 3. This is one term. Remember that terms are separated by addition and subtraction symbols. I don't have any of those here. So this is just one term, 4i square root of 3. Now you might be wondering why I moved the I from the end in front of the radical. I did that because if I were to write my answer as 4 square root of 3i, it's hard to tell if the I belongs inside the square root or not. So as mathematicians, we move that I in front of the radical to avoid that confusion. So whenever you have an imaginary number, I, with a term that has a radical, always put the I before your radical symbol. In this case, the I comes before the square root of 3. Let's try another example. On example 2, I have a coefficient. So my coefficient is that number out in front, so that number is 6. So I'm going to go ahead and write down that 6 so I do not forget about it. Next, I want to break up the square root of negative 175. And I know that I can write that as the square root of 175 times the square root of negative 1. Because 175 times negative 1 is negative 175. From here, I want to break up the square root of 175 into two factors, in which one of those factors is a perfect square. And so I know that 25 times 7 is 175. So I can break up the square root of 175 into the square root of 25 times the square root of 7. Remember that we learned that the square root of negative 1 is I. So let's simplify a little bit further. I'm going to bring down that 6. The square root of 25 is 5. The square root of 7 cannot be simplified, so I'm going to bring that down. And then I have I. Let's multiply everything that needs to go together in front of the square root symbol. So 6 times 5 times I is 30i. And then we're going to bring down our square root of 7. So our answer is 30i square root of 7. This is one term. Let's try example 3. With example 3, I have this 4 out in front. I'm going to break this up into each of their own pieces. Let's use different colors to show. Negative 28. I'm going to break up the square root of negative 28 into the square root of 28 times the square root of negative 1. Because the square root of 28 times the square root of negative 1 is the square root of negative 28. And then I also have the square root of x to the 4th. So in this problem, I have 4 pieces. We're going to look at each piece individually. So right now, there's nothing happening with this 4. It's just a coefficient that's out in front, so I'm going to bring it down. I can, let's get the right color, simplify the square root of 28 by using perfect squares. 28 can be broken up into the square root of 4 times the square root of 7, because 4 times 7 is 28. The square root of negative 1 is I. And then I have the square root of x to the 4th. X to the 4th means that I am multiplying 4 x's together. We're looking for pairs of x's to be able to leave the square root symbol. Here I have 2 x's. X times x is x squared. I do not have any x's left over, so I don't have any x's inside the square root symbol. So again, I'm going to bring down my 4. The square root of 4 is 2. I cannot simplify the square root of 7. I'm going to bring down the I, and I'm going to bring down the x squared. The only thing I have left to do is to multiply all of my coefficients together. So 4 times 2 is 8, times I times x squared is 8i x squared. And then I just need to bring down the square root of 7. Again, this is all one term, because terms are separated by addition and subtraction symbols. So our answer is 8i x squared square root of 7.